We've already looked at the sum and difference identities for cosine, and now we'll be looking at the sum and difference identities for sine and tangent. So we want to make sure that you have these on your note card or your note page, sheets of identities to work with. It's nice to be able to refer back to them quickly instead of flipping back through your notes. So make sure you get these copied down, hit pause and copy these down onto your note card or your note sheet. Couple quick things. As before, the sine of a plus b does not equal ever the sine of a plus the sine of b, and the same for tangent and plus and minus. So tangent of a plus b does not equal the tangent of a plus the tangent of b. And of course these would work for subtraction as well. So we want to make sure that you never just think you should distribute through the sign. So to get started here, let's just work on some questions. For our first one, let's look at the sine of 165 degrees. Now this is not a standard angle that we already have memorized about the sine and cosine. However, it could be the sum of a standard angle that we can work with, or to the sum or difference of two standard angles. We might think about adding, let's say 90 plus 75 would get us to 165, but the 75 is not a standard angle I know about. So I need to come up with a combination here. And I think if we look at this, this could be 180 degrees minus 15 degrees. Okay, well, does that help us though? 180 we know about, but the 15 we don't have any information about. And we could look at the 15 and do that separately, and that could be the difference between, let's say, 30 and 45. But again, we just need a single angle minus another single angle. So a couple things we need to come up with here then is a combination of the sum or difference of angles that we know from the standard angles. So I think that one that we could try is, let's try 135. 135 is a multiple of 45, and if I add a 30 degree to that, that would get me to that 165. So let's try 135 plus 30. Now remember, all of our values up here that we're working with, the sine A, cosine B, they could be degrees or radians. This problem just happens to be in degrees. Okay, so let's go ahead and copy down our formula for A plus B from up above. So we know the sine of A plus B is equal to the sine of A cosine of B plus the cosine of A sine of B. Okay, so our next step then would be plugging in 135 degrees plus 60 degrees. So it would be the sine of 135 cosine of 60 plus the cosine of 135 times the sine of 30. Or sorry, yeah, 30. I think this one should have been 30 right here. Let me write that better so it looks right. Plus 30 degrees. Okay, so I have that fixed through here. So now the sine of 135 is in quadrant 2, and it's a multiple of 45 degrees, and so the sine would be square root of 2 over 2. Cosine of 30 is in the first quadrant, so it's positive, square root of 3 over 2. The cosine of 135 is in the second quadrant. Cosine is negative in the second quadrant, so negative root 2 over 2. And the sine of 130 is 1/2, or sorry, the sine of 30 is 1/2. So rewriting these, I end up with root 6 over 4 minus root 2 over 4. And of course I can rewrite that as a single fraction, root 6 minus root 2 all over 4. Now one thing I can't do is I can't take root 6 minus root 2 and combine them anyway. So this is its simplified form. So again, the trouble with these sometimes is coming up with the right combination of standard angles that we already know about that allows us to calculate something like the sine of 165, something similar to that. Let's go ahead and work one in radians now as well. Now working in radians is a little bit harder because we don't maybe have the fraction knowledge or the combination of those standard angle fractions that will allow me to figure this out real quick. So if you have trouble with that, sometimes what you can do is convert to degrees and then work from there. So let's go ahead and convert to degrees here. And again, you don't have to do this. This is just an option. And when we convert to degrees, we're going to multiply by 180 degrees over pi. So 180 divided by 12 is the first simplification I can make, and I'll get a 15 there. and then the pi's will cancel, and it looks like I'm just left with 13 times 15, and I need to remember that's negative. So this is negative 195 degrees. Okay, so right away I'm thinking negative 180 minus 15. Negative 180 is a standard angle, but the minus 15 is not. So I need to work a little bit harder on coming up with the correct combination here. So when we're looking at different combinations here, I think we'll use that 135 again. And 135 plus 60 would give us the negative 195 if they were both negative. So let's look at that option. So let's look at the sine of a negative 135, which is a multiple of 45 degrees, minus 60 degrees. So the formula that we're going to use here is sine of alpha minus beta. Now this alpha, or this A I should say, can be a negative angle. Okay, there's no instructions saying that it can't. And again, I'm working in degree mode here. So this would be the sine of A, cosine of B. The sine stays the same here, so I have a minus, cosine of A, sine of B. So for our problem, I'll have the sine of a negative 135 degrees minus 60 degrees. So the sine of a negative 135 degrees, cosine of 60. Now I don't put in a negative 60 because the minus sign is from the formula. Minus the cosine of a negative 135 degrees, sine of 60 degrees. Now these are all standard angles that we know about. Negative 135 is in quadrant 3, so the sign is negative. So this would be negative root 2 over 2. The cosine of 60 degrees is going to be 1/2, and again that's a standard angle that we have memorized. Negative 135 is in the third quadrant, and the cosine is negative in the third quadrant, so this would be negative root 2 over 2, and the sine of 60 would be the square root of 3 over 2. So simplifying, I get negative root 2 over 4. Minus a negative is the same as a positive, root 6 over 4. And I'll write this as a single fraction. And I'm also going to write it so the leading value, the root 6 is positive, is out front. It's not necessary. You could also rewrite this as negative root 2 plus root 6 all over 4. But just be careful this negative doesn't end up out front, because that would be counted incorrect because the negative would distribute. So these are a couple of examples. And again, if you have problems working with radians, you can convert, and that might make things a little bit easier for you. But one thing you want to be careful of is thinking about all the different combinations of all the different standard angles, not just the first quadrant standard angles, but all of the standard angles that we know how to work with from the unit circle. Now this next one, let's go ahead and work with tangent. Okay, so we worked with two sines. Let's work with the tangent next. Let's go ahead and look at the tangent of 7 pi over 12. Now again, if you're good with working with radians, you can think about what fractions would this be. Pi over 4 plus pi over 3. Would it be tangent of, let's say, 3 pi over 4 minus pi over 6. You know, you can look at those different combinations so you find one that works. Or if you're not so good at that, you can convert this to degrees. And again, I'm fine with either one as long as you show all of your work. And here we would get the pi's to cancel. And 12 goes into 180 degrees. And 12 goes into 180 degrees 15 times. And then we're left with 15 times 7. And so we're left with a tangent of 105 degrees. Now I can think of quite a few combinations that could work here. So the tangent of 105 degrees could be the tangent of 45 plus 60. It could also be the tangent of 135 minus 30. These are all standard angles. There might be other combinations as well. I'm going to work with this one because we have nice first quadrant angles. So let's go ahead and look at the formula that we're going to be using. This should be the tangent of a plus b. So the tangent of a plus b is the tangent of a plus the tangent of b in the numerator. And then the denominator, I'll have 1 minus tangent a, tangent b. Okay, so let's go ahead and plug in our values. So we have the tangent of 45 plus 60. And again, if you want to use some other combination, we'll get the same answer in the end as long as we do our work correct. 1 minus tangent 45, tangent 60. Okay, now we always have to have our answer in exact form. So the tangent of 45 is going to be 1. So that's something that you could plug into your calculator and get something back out that's useful. But the tangent of 60 is not going to be a decimal that we want to plug in here. We want to get the exact value for that. So off to the side, let's go ahead and look at the tangent of 60. In case we don't have this one memorized, so this would be the sine of 60 over the cosine of 60. And the sine of 60 is square root of 3 over 2. Cosine of 60 is 1/2. Times, when you divide by a fraction, you multiply by the reciprocal. So I'm left with root 3 here. So 1 plus root 3 in the numerator. And the denominator is going to be 1 minus the tangent of 45, which is 1. Tangent of 60, which is root 3. So this looks like 1 plus root 3 over 1 minus root 3 for our simplification here. Now the next question is, do we keep it like this or do we rationalize that denominator? You should always look for the instructions to be sure what to do, but usually you do rationalize the denominator. So let's go ahead and pull this over here. And so we have 1 plus root 3 over 1 minus root 3. So what I'm going to do is I'm going to multiply by the conjugate of the denominator. So that would be 1 plus root 3 over 1 plus root 3. And the overall effect is I basically just multiplied by 1. So in the numerator, when I FOIL this out, I'll get 1 plus root 3 is 2 root 3. And then root 3 times root 3 is root 9, and the square root of 9 is 3. Now the denominator, when I FOIL this out, 1 times 1 is 1. Plus root 3 minus root 3 is 0. And then minus root 9, and the square root of 9 is 3. So simplifying, 3 plus 1 is 4, plus 2 root 3 over negative 2. So, keeping simplification here, I'd factor out a 2, and I'd be left with 2 plus root 3 all over negative 2. Now the negative in the bottom I need to make sure I keep track of, and I'm going to pop that up to the top to make that a negative 1, and then I'll distribute that, and I will be left with minus 2 minus root 3 for my simplification. That's exact form. Now if you wanted to check this on your calculator, you absolutely could. You get a decimal approximation for minus 2 minus root 3, and then you'd also make sure your calculator was in degree mode, and you'd find the tangent of, what angle were we working with here, 105, or you could be in radian mode and use 7 pi over 12, and those should be identical decimals. But this is the answer you have to report. This is the exact form of the answer. And again, we're always looking for that exact form. Now we looked at these different types of problems before where we were kind of working them backwards. We were given the right-hand side of that identity, and then based on that right-hand side we wanted to come back and say, okay, well, what is this the sine or the cosine of? Okay, so let's write this one out. Now so far this looks like it's fitting the form of definitely sine, because cosine had cosine, cosine, sine, sine. This one alternates. So this is definitely the sine, and it has a subtraction in here. So the sines should be 79 degrees minus 19 degrees. Okay, so simplifying then, we get the sine of 79 minus 19 is 60 degrees, and the sine of 60 degrees, continuing to simplify, is one that we have memorized as the square root of 3 over 2. And again, you could plug all this into your calculator if you were in degree mode, and then plug root 3 over 2 into your calculator, and those decimals should be identical. However, this is the value you need to report because this is exact form. So always make sure you're reading your directions in My Math Lab and on your exams. It should be in exact form, but you can check with your calculator, so that's nice. Let's look at another example. Let's look at the cosine of 60 degrees minus theta. Now this is a little bit different because this is from a previous section. So look on your note card or your note sheet, and let's go ahead and look at what is the cosine of alpha, or a minus b I should say, cosine of a minus b. It's going to be the cosine of a, cosine of b, sine will switch, and this will be sine of a, sine of b. And then we plug in our values. So this would be the cosine of 60 degrees cosine of theta plus the sine of 60 degrees sine of theta. Okay, so the cosine of 60 is 1/2 cosine of theta. And the cosine of theta I don't really know anything about because I don't know what theta is. The sine of 60 degrees is the square root of 3/2 sine of theta. And again, I don't know what theta is, so I have to leave these in terms of cosine and sine. So if we rewrite this as a single fraction, this is going to equal cosine of theta, and always put parentheses around the arguments of your trig functions, plus √3 sine of theta all over 2. Okay, so that's a simplification. That's the closest we can get. Now this one we can't really check on our calculator because I have still cosine and sine variables that I can't really plug in or check for. So this was using not information from this section but a previous section. So make sure that you always keep that note card handy or that note sheet handy. We're getting a lot of information on it, so it's probably turning into a sheet. Okay, let's look at another one, sine, and let's do pi/4 minus x. So the first thing that we'll want to do is to figure out which formula I need, or which identity I need. This would be the sine of a minus b, and that's going to equal the sine of a cosine of b minus cosine of a sine of b. So again, always write out what you're using for your identity and then you can plug in. So again, pi/4 minus x. This will be the sine of pi/4 cosine of x minus the cosine of a, which in this case is pi/4 sine of x. So sine of pi/4 is square root of 2/2 cosine of x. And I don't know anything about x, so I have to leave that as is. Cosine of pi/4 is √2/2 sine of x. And then I can rewrite these as a single fraction. So this would be √2 cosine x minus √2 sine x all over 2. Now you might be tempted to maybe cancel the numerators out, but remember one is cosine and one is sine, so they're not technically like terms, and if they're not like terms I can't cancel those. So these are the same types of problems that we did for cosine that we are using for sine and tangent now. Now if you remember from our last section when we were working with cosine, there was a pretty long problem where we were given some information about the angles in different quadrants. And then we had to kind of work from there, either using right triangle trig or using unit circle trig or some of our identities to solve. So in this case, we're going to be finding three things. S plus t. Actually, let's do sine s plus t. We're also going to find tangent s plus t. And then let's also find what is the quadrant of s plus t. Now this isn't either one of the trig functions, it just says the angle s plus t. Where does that quadrant lie? So we have to be given some more information to do this, and so the information that's being given to me is that the cosine of s is equal to -5/13. And I remember when I was working this problem, I forgot to notice where quadrant or where s was, and it's in quadrant 3, so I'm going to write this right away. And sine of t is -3/5, and that's also in quadrant 3. So in quadrant 3, sine and cosine are both negative. Tangent should be positive when I get done. So let's go ahead and work with s first. If you wanted to, you could use your right triangle trig and you could say, okay, this is adjacent over hypotenuse and work from there. I'm going to go after sine squared plus cosine squared equals 1. So I'll write down the formula I'm using, or the identity I'm using. I do not know sine squared, so that stays. However, I do know cosine. That's -5/13, and that should be quantity squared. Both the numerator and denominator will be squared. So this should be 25 over 169 equals 1. Solving for sine squared of s, I'll get 1 minus 25 over 169. Finding a common denominator, would be 169 over 169 minus 25 over 169 equals 144 over 169. So that would mean sine squared of s equals 144 over 169. Now to solve from here, I could say the sine of s would be plus or minus the square root of 144 over 169. But remember, we're in quadrant 3, so this is what I know about quadrant 3. The sign is negative. So sine of s is equal to the negative. Square root of 144 is 12. Square root of 169 is 13. So there's the sign, negative 12/13. So this is what I know about s. I know the cosine is negative 5/13. I know the sine is negative 12/13. The sine of s is negative 12/13. And I know something about the tangent as well now. Because remember, the tangent is sine over cosine. So if I take sine over cosine, I'd end up with a positive 12/5. So if I take the sine negative 12/13 divided by 5/13, I would flip that. The 13s would cancel. And negative divided by negative is a positive, so I'd have 12/5. So this is kind of the big information that I need to know to work this problem for s. I need to come up here and do the same thing for t. And again, if you wanted to, you could work this for t using right triangle trick, or you could use like we did with the unit circle information or the identity information. So again, we start with sine squared of t plus cosine squared of t equals 1. So I have the sine is negative 3/5, and that's squared. That's quantity squared, so you need to have the parentheses around that. Plus cosine squared of t equals 1. So negative 3 times negative 3 is 9. 5 times 5 is 25. So I end up with cosine squared of t equals 1 minus 9/25. Find that common denominator. Is 25 over 25 minus 9 over 25. Cosine squared of t equals 16/25. Cosine of t would be plus or minus the square root of 16/25. Now something to keep in mind here, I know I'm in quadrant 3 as well. So that means cosine is negative. Square root of 16 is 4, square root of 25 is 5. So that's negative 4/5. So I have a lot of information here that I can summarize. So for t, I know that the cosine of t is a negative 4/5. I know the sine of t, and that was given to me. The sine of t was negative 3/5. And then from here I can figure out what the tangent of t is as well, because I'm going to need those values. So tangent is sine over cosine. So if I take sine negative 3/5 and divide it by a negative 4/5, I would flip that and I'd end up with a positive 3/4. So this is our important takeaway information that we'll need to solve for the 3 things that we were asked to solve for. Now the first thing that we were asked to solve for was the sine of s plus t. So let's go ahead and write out the formula that we'll use. The sine of s plus t will be the sine of s. Cosine of t plus cosine of s sine of t. Well, we know all of these values from right up here. The sine of s is negative 12/13. The cosine of t is a negative 4/5. Plus the cosine of s is negative 5/13. And the sine of t is a negative 3/5. Okay, so now simplifying, negative times a negative is a positive, so this would be 48 over 65, 13 times 5 is 65, plus negative times a negative is a positive, 15 over 65. So adding those two together, 48 plus 15, I would end up with 58 plus 5 would be 63/65 for s plus t. Next thing we were looking for was the tangent of s plus t, and then the quadrant of s plus t. So let's look at the tangent of s plus t. So first thing we'll do is we'll write down the formula that we're using. You should always do that. That's something I'll be looking for when I'm grading, because if I don't know the formula you're using, it'll be difficult to give credit for that. So the tangent of s plus t would be the tangent of s plus the tangent of t over 1 minus tangent s tangent t. Now it looks like we're going to have some layered fractions here, so we're going to have to be able to work with those. Tangent of s was 12/5, I already have that, plus tangent of t was 3/4, all over 1 minus 12/5 times 3/4. So I definitely have some fractions that I need to work with here. Now there's several different ways that we can do this. Common denominator here is definitely 20. So one thing I could do is multiply top and bottom by 4 here, top and bottom by 5 here, top and bottom by 20 here. Another thing I could do is I could have multiplied top and bottom through by 20. So again, several different ways that we could work through this. So this would be 12 times 4 is 48 over 20, plus 3 times 5 is 15 over 20, all over 20 over 20, minus 12 times 3 is 36 over 20. Writing this as a single fraction, 48 plus 15, 58 plus 5 is 63/20, all over 20 minus 36 is a negative 16/20. And remember, when you divide by a fraction, you're multiplying by the reciprocal. So I'm going to multiply by negative 20/16. The 20s will cancel, but remember there's a negative here, so you're left with a negative 1. So this is a negative 63 over 16 for the tangent. Now remember and keep in mind that we're asked to find one more thing, and we're asked to find what quadrant is s plus t in. So let's look at the information we have. We have that the sine of s plus t is positive, that's from right up here, 63/65. And we're given that the tangent, or we found that the tangent of s plus t is negative. So we need the sine to be positive and the tangent to be negative. So if we think about this, the sine is positive here in the orange, and tangent will be negative in quadrant 1 or 2. Well, it's going to be negative in quadrant 2, where the cosine is negative and the sine is positive. So our answer here will be, which quadrant are we in, would be quadrant 2. Okay, so this is a really good problem because we're looking at a lot of information about what quadrants we're in, about sines and cosines, either using right triangle or unit circle. So this is a really good type of problem to have on an exam because it tests a lot of different pieces of information. Now the last type of problems that we're going to be having here are going to be basically establishing an identity. Now in my math lab, they usually give you like 4 or 5 options to choose from on which one is correct to establish an identity. But remember, on the test you'll be doing these by hand, so you won't be given those guideposts. You'll be able to choose the own direction that you want to take. So let's look at an example of establishing an identity. We're going to use cosine of alpha plus beta over cosine alpha cosine beta. And we want to establish that that is equal to 1 minus tangent alpha tangent beta. So our directions are usually to start with the more complicated side and then work from there. So if we look at this, I think the more complicated side could be the left because it's a layered fraction and I have a sum of 2 angles. So let's go ahead and start with the left. Now on the test, let's say you were working this problem and you decided to start on the right. That's absolutely fine as long as you have all of your steps and work shown. Okay, so from here, what we can do is the cosine of alpha plus beta, that's going to be a sum identity for cosine. So this would be the cosine of alpha, cosine of beta. Sine is different, so this should be one that's on your note card or your note sheet. minus sine alpha sine beta. And that's all over cosine alpha cosine beta. Now it's tempting at this point to say, well, wait a minute, that's in the numerator and the denominator. I should cancel those, but you can't do that. And the reason you can't do that is that same information in the denominator also is under here. And if I cancel it over here, it's no longer possible to divide through by that. So I can't do that. It's tempting, but I can't do it. The way I need to deal with that is to actually rewrite this in two fractions. So this would look like cosine alpha cosine beta all over cosine alpha cosine beta minus sine alpha sine beta. So I'm splitting this up into two different fractions, cosine alpha cosine beta. So now this cancels and we're left with a 1. And then here, sine over cosine is tangent, sine over cosine is tangent. So I'm left with 1 minus tangent of alpha, tangent of beta. And that is what I was trying to show, so that identity has been established. So again, here I had to make sure I could call back to the sum formula for cosine, the sum identity for cosine. So anything on the sheet is fair game. So we're not just working kind of in a closed box where we can only work with sines and tangents in this section. Let's go ahead and look at one more, establishing an identity. These can be a little bit long, and I want to make sure that you have some resources to look back on when you're working through these homework problems. And also, these are the types of problems that you'll be seeing on your exam. So by watching the lectures, you're getting a lot of problems that could show up on a test. So it's good that you're watching these. Hopefully they're helpful. I know they're long, but they have a lot of good detail for you as well. So what we're trying to do is establish this identity by showing that these are equal. Now I could start with either side. I think on this one they're both fractions, they're both sums and differences. So I think the more complicated side to me on this one is tangent. And again, if you think it's the left hand side, that's okay. You can start with that. Just make sure you show all your work. There's always more than one way to do these problems. So this one's going to get pretty scary pretty fast because I'm going to take everything and rewrite it in terms of sine and cosine. So this is going to be equal to the sine of x over the cosine of x plus the sine of y over the cosine of y all over sine of x over cosine of x minus sine of y over cosine of y. Now from here there's several different ways I can simplify. You're probably getting used to that now. You can take more than one approach, but I think that what we'll do here is to find a common denominator, and then once I have a common denominator, I'll definitely have layered fractions here. I'm going to have to remember that when you divide by a fraction, you actually are multiplying by the reciprocal. And we'll use that information to continue to solve and hopefully to get the right hand side out of this when we're done. So our common denominator here would be cosine x cosine y. So I'm going to multiply cosine x top and bottom here. And over here I'll multiply cosine y top and bottom. Okay, here we have cosine y then that we're missing top and bottom. Here we're missing cosine x top and bottom. So this is equal to sine x cosine y plus sine y cosine of x all over cosine x cosine y. Okay, so that's one fraction. Now to kind of keep track, I'd make this fraction bar bigger so we can definitely see the difference between the upper and lower fractions. Then I'll be left with sine x cosine y minus sine y cosine of x, and this is over cosine x cosine y. Now again, this big fraction bar is kind of splitting us up into that numerator denominator. So remember, our rule is when you divide by a fraction, you multiply by the reciprocal. So I'll have sine x cosine of y plus sine y cosine of x all over cosine x cosine y. And this is, we're going to flip this and multiply. So we're going to divide by this fraction in the denominator, but when you divide by a fraction you multiply by the reciprocal. So this sine x cosine y goes to the bottom, minus sine y cosine x, and in the top we'll have cosine x cosine y. Now these cancel, so that's making things a little simpler here. And then my numerator is sine x cosine y plus sine y cosine of x. And hopefully this is looking like an identity that we learned today. Over sine x cosine of y minus sine of y cosine of x. So if you look back on your identity card or your identity sheet, this top one would be the sine of x plus y. In the bottom, the denominator would be the sine of x minus y. And again, this is what we were trying to establish. If we come clear back up here. So I've established the identity. I've started with one side, a more complicated side, and I'd work toward the other side. So these are pretty straightforward if you have that note card or your note sheet with you. I would always keep that with you because you're going to start to recognize some of the patterns and some of the values that you have. And again, if you have problems with working with radians and you're not so good with radians, just convert everything to sines and cosines in terms of degrees, and you can work straightforward from there. If you have to convert back when you're done, go ahead and do that, but usually you're just finding exact values of the function and not the angles themselves. So as usual, if you have any questions, let me know, and good luck.